Hello and welcome back. We are looking at 10.7, which is all about secants and our circles. We did talk about secants in 10.6, but that had to do with angles and arc measures. This is all about lengths of the segments, lengths of these secants. So we're completely just talking about the length of lines here. So there's no angle measures or anything like that really involved in this section. So again, we're going to have some formulas you're going to have to remember, some patterns, 10.6. So just kind of bear with me and practice as many of the examples as possible, many, many times, so that you can understand which type of formula or pattern needs to happen with each type of question. So the first thing that we have is if we have two chords. So if you look at our image over here to the right, we have a circle A with points A, D, C, E on the sides. So I have chords AC and chords ED. So they're not leaving the circle. There's nothing outside of the circle. They're just crossing on the inside of the circle. And what I want to do is find the lengths of all of the pieces and solve for X. So if we have chords, two chords that intersect in a circle, then the products, what does that word mean, guys? Products means we are going to multiply. My pen is writing all sorts of funny. Multiply the lengths of the chord segments. Then the products, when we multiply, of the lengths of the chord segments are equal. So when we are talking about the segments of the chords, we're talking about the two segments that belong together. So if I'm looking at one chord, I'm looking at section A and section B together. Those two are going to be multiplied together. They're going to be set equal to the other two, C and D, being multiplied together. It's kind of like we're cross multiplying, if you want to kind of think of it like that. Honestly, that kind of might work for some of y'all. So if you want to think about it as cross multiplying, you're more than welcome to. But the two pieces from the same chord get multiplied together. So if I look at my first example over here, I'm going to go through and label or color code to match my picture a little bit. So if I have 12 is alongside this chord AC, so it's going to pair up with 5. So I'm going to say 5 times 12 is going to be equal to, and I have 10, which is along ED, and so that's going to be multiplied to X, which is also along ED. So X times 10. 5 times 12 is 60. X and 10, divide by 10, divide by 10, and X is equal to 6 units. So you take the pieces that are along the same chord and multiply them together. And we have secants and secants that are outside the circle, so not just chords. These are secants that are touching each other outside of the circle. They don't cross inside of the circle. And we have two sections of those as well. We have A and B and C and D. So those are all cut into sections as well. This one follows a little differently, is I'm going to multiply the whole length of the secant. So all of A and B together. So you would be adding them. So A plus B. And then I'm going to multiply that to just the portion that's on the outside, just B by itself. And that's going to be equal to all of DC. We're going to add those together and multiply it to just the portion that's outside by itself. So we're taking the whole segment, multiplying it to the portion that's on the outside, and setting that equal to the other whole segment and multiplying it to the portion that's on the outside. So if I take a look at my example to the side here, the whole, that was kind of messy, the whole length of this piece is x plus 8. And then we have the smaller piece, just 8. And on the side, we have 10 plus 6, which is going to give us 16. So I'm going to take x plus 8, which is the whole thing. The outside is just 8. And set that equal to the whole outside of 16 times just the outside of 6. And now I'm going to go through and distribute and solve for x. Got 8x plus 64 equals 6 times 16, which is 96. Subtract that 64 and you get 8x equals 32. So x has to equal 4 units. And then we will have secants and tangents. So remember, a tangent does not go into your circle at all. It's over here. It just touches the edge. And then we have the secant, which goes into your circle. So you've got a little bit, one that's just on the outside, then one that's on the outside and inside. So similarly to the secant one we just did, we're going to take the whole of the secant, so a plus b, and multiply it to just the outside. And then we are going to set that equal to the tangent squared. Basically going to multiply the tangent to itself. So if I look at my example over here, this is my tangent. And this is my secant. So I'm going to look at the whole thing, which is x plus 4. And I'm going to set this up as x plus 4 times 4, which is on the outside. And that's going to be equal to my tangent squared, which is 6 squared. Go through and distribute. 4x plus 16 equals 36. 4x is equal to 20. So x is equal to 5 units.